Okay, this is AP Calc BC 2022 FRQ number 1. So first we're going to do part A, write but not evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 a.m. to 10 a.m. and then they give you the t equals values of 1 and 5. So this is quite a simple one. So here at the bottom, we're just going to take the rate and integrate it from the times that it says. So it's going to be the integral of 1 to 5 of the ax or at function, which is 450 square root of sine 0.62t dt. And that's it. That's the integral function, and it doesn't want us to evaluate it, so we're done with part A. Part B, find the average value in vehicles per hour at which vehicles arrive at the toll plaza from 6 a.m. to 10 a.m. So this is a very similar integral, but we have to use the average value function. So average value formula is 1 over b minus a integral of of a to b, and then this is we're going to plug in the same function, so 450 square root of sine 0.62 t and dt. Now we know our a and b value because again those are given. 6 a.m. or 1 is a, and 10 a.m. or 5 is b. So it's going to be 1 over 4 integral 1 to 5 of 450 square root of sine 0.62 t. Okay, and now this is a calculator problem, so I'll just pull out my calculator and evaluate the following expression. Okay, after plugging it in, I get a value of 375.5369. So we'll round that to 375.537. One note in case you're getting a different answer is make sure your calculator is in radians, so the sine function gets the correct return values for this. And then in these problems, it's very important to do the correct units. So it's asking for vehicles per hour. So in the average of that, so we have to do units of vehicles per hour. Okay, on to part C. Is the rate at which vehicles arrive at the toll plaza at 6 a.m. t equals 1 increasing or decreasing, and give a reason for your answer. So by far the easiest way to do this, especially with a calculator, is just to plug in the derivative of the function at the specified value. So for part C, we're going to evaluate the derivative at 1 and see if that's positive or negative. So I'm just going to quickly plug that into my calculator. Okay, I plugged it in, and I got 148.947, which is positive. So, because the derivative of the rate is positive, the rate at which vehicles will arrive at the toll plaza at 6 a.m. is increasing. So I'll just write that out, and we'll get on to part D. Okay, I've written it down, and now on to part D. So a line forms whenever A of t is greater than 400. The number of vehicles at time t for a is less than t, which is less than 4, is given by n of t equals the integral from a to t of a of x minus 400 dx, where a is the time when the line first begins to form. To the nearest whole number, find the greatest number of vehicles in line at the toll plaza in the time interval a is less than t, which is less than 4, and justify your answer. Okay, so right away we know we have to find the a and t values, and this is probably most easily accomplished via a calculator. So before I even evaluate any integrals, I'm going to find those. So first, I'm going to graph the line y equals 400, and then I'm going to graph the rate, which is the 450 square root of sine 0.62t. And then I'm going to find the intersection points of the two graphs on the interval 0 to 4. And then once I do that, I now have my bounds of integration, and then I'm going to integrate this function on my calculator. So I'll get back to you when I have the a value, which is the start of when the line begins to form, and the b value of when the line stops forming and starts shrinking. Okay, here's the a and b value. So at 1.469 hours, the line begins to form, and at 3.560 hours, the line starts to shrink. So if we integrate the function n of t by A and B, we will get the maximum amount of people in line at a given time. Okay, so I'm just going to plug this integral into my calculator, and I will get back when I have the answer. Okay, I plugged it in, so this is the integral we have to plug in, which is n of t, as I wrote before. We have our bounds of integration, which we found through calculating the intersections of the lines with the calculator. And then one important note is we have to round it to the nearest number of cars, because you can't have 0.187 of a car. So the correct answer to this problem is 71 cars. Now we only have to justify our answer. So for our justification, the math works pretty well, but I'm just going to write a little sentence at the end, so I'll get back when I write it. Okay, so here's my explanation. Basically, I said, since the line starts to form when 400 is less than the rate, it's accumulating cars, the line will begin to shrink when the rate is less than 400, and so cars will be exiting faster than they're leaving, and then integrating from these t values must yield the maximum length of the line, because it's when the line forms to when the line ends.